Welcome to part 2 of lesson 4.3. I'm going to go right into kind of a new topic. Again, it should be review from last class, but reviewing stoichiometry and what that means and why it's important. Stoichiometry is the section of chemistry that involves using relationships between reactants and products in a chemical reaction. That sounded like I was done and I'm not. To determine desired qualitative data and molar ratios. And this is really the big thing in stoichiometry, is this idea of molar ratios, okay? I'm going to give you an example of a chemical equation, and let's say that we have rubidium phosphide, and that decomposes into rubidium and phosphorus, okay? This equation is not balanced because we have 3 rubidiums on this side and 1 phosphorus. We only have 1 rubidium and 1 phosphorus here. So in order to balance it, we need a 3 here, okay? So now we're balanced. What stoichiometry is, and this can be very, very complicated, or it can be very, very simple. What stoichiometry means is that each coefficient represents the number of moles in a molar ratio. This is why balancing is important. So these coefficients here, I'm just going to put a 1 here and a 1 here. This means that 1 mole of Rb3p is equal to, we just use the coefficient, 3 moles of Rb. Now, 1 mole of Rb3p is also equal to 1 mole of phosphorus. And again, that's all that it is. These numbers now gain significant importance because you can convert between moles of one substance to moles of another completely different substance just by looking at the balanced chemical equation, okay? Let's look at an example of how this can apply to what we're doing. And I'm going to use this idea of decomposition again, but it's going to be the decomposition of something that we should be familiar with from biology, and that's glucose. Okay? And glucose is C6H12O6. And when that decomposes, you get C2H5OH plus carbon dioxide gas. C2H5OH is something called ethanol. It's a form of alcohol. CO2 is carbon dioxide. If we were to balance this, we have 6 H's here, 3 carbons, and 3 oxygens. We have 6 carbons here, 12 hydrogens, and 6 oxygens. So if I double this one, this is going to give me 4 carbons, 10 hydrogens, and I'm sorry, there should only be 1 oxygen here. So now we have 2 oxygens. And if we double this side here, we'll now have 6 carbons. Oh, sorry, this should be 12. I'm making mistakes. And this should be 6. So now we're balanced. Now, what if the question says if 17.5 moles of ethanol are produced, how many moles of glucose were in the beginning of the reaction? Okay. So it's saying at the end of the reaction we have 17.5 moles of ethanol. But it's asking how much should we start with? And again, very simple. We're using dimensional analysis. We want to start with what we're given. So we have 17.5 moles of C2H5OH. Now, we know based on the chemical equation that 1 mole of glucose is equal to 2 moles of C2H5OH. So our math is just 17.5 divided by 2. Our moles are going to cancel. I got this directly from the balance equation in a 1-to-2 ratio. It's going to give us 8.75 moles of C6H12O6. Super simple. And you can see here that my significant figures are in agreement. Now we can go one step further with this, and this will be my last example. And we can say, instead of calculating the number of moles, we can go an extra step and say, let's calculate the mass of ethanol produced if 5.00 grams of glucose decomposes. Okay. So now we're given 5 grams of this, and it goes through the entire reaction. How much of this is produced? How do we do that? Well, we have to start with glucose. And we have to somehow end up in grams of C2H5OH. And it's kind of like a little puzzle. So first we need to go to grams of glucose. And I have the molar mass here that I calculated earlier. You just add all these on the periodic table and you'll get 180.56. And that's gonna give us 1 mole of glucose. Now we know based on the balance equation that for every 1 mole of glucose, we have 2 moles of C2H5OH. And we can again calculate the molar mass of this. 1 mole of C2H5OH is 46.068 grams of ethanol. And if we do this math, we should get the amount of ethanol that we created. And I'm just doing it right now on my calculator because I don't have an answer for this. And I got 2.56 grams of C2H5OH. Okay. So again, this step, converting from one substance to another substance, is super, super important. We have to make sure that we do this step. Otherwise, we're going to be stuck with glucose the entire time. We need to be able to move to ethanol. All right, stay tuned.